Okay, do you guys remember what I said about curve sketching when we did it on Thursday? About like the level of importance of actually drawing them. Not necessarily unimportant, but we're not going to have to do it on the AP exam most likely. I would be shocked to see one on there. That the more important part about this is that you can relate the graphs to one another. That you can see how the function itself can be seen in the derivative, that you can see how the derivative can be seen in the second derivative. That's the more important part. So when you look at that, when you look at this problem, could you probably sketch y equals negative sine x without doing anything? Yes, probably, because you've learned it before. I'm not trying to make your life hard by doing this problem. I am having you do this problem instead of a harder problem, because I think we can do the process on it and go like, that was interesting, instead of doing a harder problem where we get frustrated. Does that make sense? Okay, so don't look at this and be like, Ms. Rice, this is stupid, we could just graph that, because then I'll be like, fine, I have to give you a more difficult one instead then. Does that make sense? I'm giving you an easier one, but we're still gonna practice the process, okay? Same thing with this one. You could probably graph it without this process, but that's the point of today, is we're going to practice it. Then when you get to some of the other ones, they're actually ones where without a calculator you probably wouldn't know what to do, so we're actually going to do those. But again, I chose more simple problems rather than like super complicated ones. Okay, so today it's just about like making the connections and making sure that we understand how everything relates. Okay, so if you compare this to your last curve sketching assignment, the part 1 assignment, what should we do first? Yeah, x-intercepts, y-intercepts. On this page, I said if the x-intercept is difficult to find, don't sweat it. So for 1 and 2, you can find the x-intercepts, but for the other problems, you're probably not going to, because it's not going to be worth the effort. Okay. So for here, I'm going to find the x-intercept by doing what? That wouldn't get the x-intercept. That would be the y-intercept, but we can go ahead and do that. So let's go ahead and find the y-intercept first, because honestly, that's the easiest thing to do, right? So we'll say plugging in 0. What happens when you plug 0 into a sine equation? Gives you 0. So that's actually an x-intercept and a y-intercept. Okay, and then we said to find the x-intercepts, we just need to take the function and set that equal to 0. So that means that sine x equals 0, x equals 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, all of them, except this one is telling us that we're only graphing it on the interval from 0 to 2 pi, and so that means we're only going to use these 3. So if I'm keeping a list of all the things that I can find, I'm going to say my x-intercepts at 0, 0, pi 0, and 2 pi 0. My y-intercept is just at 0, 0. I can go ahead and graph those. I tried to make the graphs like, 7 pi fourths, 8 pi fourths will be over here. I tried to make it so the graphs were not dumb, because the software I was using, anyway, all of them, 2 pi is like at the end of the arrow. I apologize for that, but to be honest, I was like, I'm not about to go do this all over again. So I just left them, okay? So just be comfortable with that. 2 pi is over here. All right, so what do we do next? Yeah, derivative A. Yeah, that's derivative in, okay, I was trying to translate what language that would be. Derivative in slang, in tired. There we go. So y prime is negative cos, okay? Okay. And what do we do with the derivative and the second derivative? We set them both equal to 0, equals 0, equals 0. So we already know sine, right? What are those? Okay. And then what about for cos? Where does cos equal 0? Okay. So for this, we need to draw a number line. That's going to help us find what? What does the first derivative help us find? Increasing and decreasing. And then what does the second derivative help us find? The concave up and concave down and point of inflection. And then what do both derivatives help us find? Depending on how you use them. Starts with an R. Relative max and relative min. You can use either of them to find relative max and relative min. Okay, so what's a number between 0 and pi halves? I'm going to put pi right here. That's okay. Pi fourths. All right, so it says negative times cos of pi fourths. Pi fourths has an x coordinate that is positive. So if we're doing negative times a positive, what do we get? Negative. Cos of pi has an x coordinate that is negative. So negative times negative is positive. And then what's the number that's between 3 pi halves and 0? 7 pi fourths? Yeah, I said, yeah, but I got distracted because you started talking. So 2 pi, thank you. So between 3 pi halves and 2 pi would be 7 pi fourths. 7 pi fourths is going to have an x coordinate that is positive. So negative times x coordinate that's positive is negative. Okay. So what does that tell us? Okay. What does it tell us about increasing? Do you guys want to do the relative max and min now, or do you want to wait? No? Okay. Okay, so relative min, relative max, relative min is at pi halves, and oh, you plugged it in already? Don't cheat. Don't cheat. We're doing all this. We're doing all this. We're thinking through it.
Plug it into a sine graph, it's 1.
All right, so if we take the original problem and we say negative of sine of pi halves, what do we get? Everyone except for Toby. We get negative of 1, so that's negative 1. And then if we do negative times sine of 3 pi halves, positive 1, we get negative of negative 1, which is positive 1. Okay. All right, and then for this one, what's a number that's between 0 and pi? Pi halves. So at pi halves, the y coordinate is positive, and we're just plugging it in here. So it's going to be positive. And what's the number between pi and 2 pi?
3 pi.
And at 3 pi halves, the y coordinate is negative. So it's going to be negative. So concave up is 0 to pi. Concave down is pi to 2 pi. The point of inflection is at pi. And we have, we have already found that x and y coordinate. It was one of the x-intercepts. So I'm not going to do the work again. I'm just going to say that the y coordinate there is 0. Now, in the instructions, I said to find all these different things. And then I also said in the instructions that it might be helpful to find the endpoints of the curve. So we know that one endpoint is using an x coordinate of 0. We already found the corresponding y coordinate for that one. The other endpoint is an x coordinate of 2 pi. We already found the corresponding y coordinate of that one. So we're basically done. But in some of the other graphs, it's going to be helpful for you to take 2 pi and plug it in. Okay, and this one you don't really need to because you had it already, but for some of the other ones it'll be good. Okay, so for us to sketch the curve, what else should we plot? We do too. Max and min, we can plot those. Well, we didn't plot them. All right, well, pi halves -1, and then 3 pi halves +1. All right, and then what do we do? Yeah, so it says it's decreasing from 0 to pi halves, and then from 0 to pi, it's concave up. So we know that this is going to be kind of this shape. Yep. And then we know from pi halves to 3 pi halves is going to be increasing. So this should be going up. We know that from pi to 2 pi, it should be concave down. And then we knew that from 3 pi halves to 2 pi, it was decreasing. So that fits all the information we had. Should we be drawing arrows on either end? No, because this was a segment, closed interval, doesn't go forever. Okay, so these are all the things that helped us draw it. Ta-da! Look how fun that was. Wasn't that fun? All right, so this is the whole assignment. There is a video tonight. The video tonight is going to feel redundant for some of you who understand everything really well. You're going to be like, yeah, you already said that. Up until you get to the end of the video, and then it's going to be like, okay. But I expect you to write down the whole thing. Okay? It's 20 minutes. Okay. So work on this. I don't expect this will take you the whole period. If you are like working on it, you'll probably finish it. So if you get done, what could you work on? Cheat sheet, problem set, video notes. I added a little bit more to the cheat sheet requirements because they weren't updated up through this stuff, so now they are. Okay? Next Tuesday, I believe. Yes, yes, the website is up to date. So that means Monday study session, Tuesday test. Okay. We're all good? We know what we're working on? Yes? Marvelous? Okay, I'll put the answer key in the back for you.